Hi, everybody. This is Bill Bittner. It's Monday, August 3rd, 2020. And with us today, we have Bruce Hayden back to talk to us about directory maintenance with DirMaint. So with that, I'll turn it over to Bruce.
Thank you, Bill. So what is DirMaint in relation to the system here on ZVM? The user directory of ZVM, of course, that's how you define all the virtual machines. That's just a CMS text file, in its source form. And how do you update it? You edit it, right? And so if you got a bunch of different system programmers, or you want some type of organization, or, certainly allocating mini disks on DASD is kind of a manual, time-consuming process. Gee, we have this program that can manage it for you. So it's called the Directory Maintenance Program, or DirMaint. That's what we have here. It's one of those priced optional features of ZVM. So it's not included with the basic system. I mean, it's installed, but it's not, you don't use it unless you paid for it. And the reason there is, I guess, one, you get some money for it, but two, there are competitive products. So CA has a directory manager product. That's at least one of them, may be the only one. So, you can have a choice on which one you want. So it has a command interface. I mean, it's a command line type tool. It doesn't say here, but if you're using the system management APIs, it requires a directory manager, of course, to work with the directory. And so it has that kind of interface too for the system management APIs. Certainly it checks what you do, so you make sure you have a valid directory out there. One of the most important things it really does is this automated mini disk allocation and deallocation. So when you want to add a mini disk to a system, instead of saying, well, gee, I've got this spot over here that's nobody's using, I think, I'll put it here. DirMaint takes care of that for you. You say, okay, I need 100 cylinders here, or do I just need 100 cylinders in this set of volumes? And it goes and finds unused space and does all that. Or when you deallocate a mini disk, it cleans it up, meaning it formats the space. So, there's no residual data there, that kind of good stuff. And of course, it can copy also. It, of course, keeps a transaction log. It can keep a transaction log. It can even keep that in RACF audit data. So you have a record of what happened, which is also good if you have multiple people working with the directory. We're going to go see these service virtual machines that basically do the work, DirMaint, DATAMOVE, and DIRMSAT. In an SSI cluster, it's also really important as well, because if you're manually managing your directory in an SSI cluster, then you're basically logging on to every member of that cluster to put the object directory online. You have to do that all the time. And it's really easy, and I can speak from experience because I have a system or two where I've done things more manually, that it's really easy to put the directory online on one system and forget to do it on the other, and then think, well, how come that change isn't in the system here, where it should be? If you have an external security manager like RACF, DirMaint has ways to basically coordinate its changes with RACF. So as you make changes to DirMaint, corresponding changes are made in RACF. As you can imagine, adding users, deleting users, mini disks, things like that. So that works rather well also. So how does DirMaint do what it does here? And so you kind of a simple picture here, and we'll go to a more complicated picture on the next page for an SSI cluster. But in the most basic sense, on a single system, you have two virtual machines, DirMaint and DATAMOVE. That's what that's showing. And users or system administrators work with DirMaint via the command line interface. So they're CMS commands, basically. And so they enter those commands, which are sent to the DirMaint machine, which are executed and either done or responses sent back or whatever. And you have two classes of users, or really multiple classes, but let's just think of it as an authorized user and a general user. Most customers don't care about this so much because these days running Linux workloads, probably the only users on their system from a logon point of view are system programmers, or basically authorized users. But us inside IBM may still have and do have virtual machines where we work with VM for development or whatever. And we may be general users to DirMaint. So we can link to somebody else's disk. You may be authorized to do that. There's certain things you can do as a general user. You can certainly look at your directory entry. And so we see more of that. DirMaint works with these things on the other side, the source directory files. It has, of course, configuration files, other configuration files that talk about password rules, who's authorized, that kind of stuff. And we'll see those as we go through here. So that's this more simple picture of how DirMaint works. In an SSI cluster, you have, of course, multiple members. This is showing a 3-member SSI cluster, just as a picture here, and you see some of the actual mini disks that DirMaint uses. So that one in the middle is the one dog fox disk. That's where the source directory lives. And so this DirMaint machine, you notice there's only one ID here called DirMaint in all of these members. So that he's only logged on in one place. And he can run on any member, but typically he probably runs on your slot one because that's maybe the first one that came up. But that guy has a read-write link to the source directory disk, the one dog fox disk. And so he's what's updating the source directory. These satellite machines, so they run on the other members of the cluster. You'll notice they have maybe 2 or 3 in their name. They have read-only links, so they read it. But they're the guys that are actually updating the object directory on those systems. So you notice every system has an object directory and somebody pointed to it. On VMO1 over here, it's the DirMaint machine that does that. There is no satellite machine that runs over here. And of course, we still have DATAMOVE machines, which we'll talk about what they do. We have authorized users and general users on any system, and basically they can issue DirMaint commands, and they're directed to the satellite server on the other members. And then those satellite servers work with the DirMaint machine when they need to, if they have a source directory update or something like that that needs to be done. So you can see that each system has its own object directory, and maybe hopefully you're familiar with that just from a general SSI cluster configuration, but there's only one source directory, and the DirMaint machine, wherever it runs, is the one that does those updates to the source directory. So from another member with a satellite server, basically if you ask for a source directory update, it's basically relayed to the DirMaint machine and he makes that update. And then of course the arrow points both ways, because then he tells the satellite server, oh, you need to update your object directory because I updated the source directory, and that's what the satellite guys do. So that's a pretty quick overview of how it works in a cluster, but we'll see a little more of the internals and that kind of stuff, and talk about exactly what all of these servers do as we go through here. So we've seen some of this. The DirMaint server, he owns and manages the directory, so he's the one that is really making the updates and checking things and all that kind of stuff. Under the covers, he's using DirectXA, which is what you would use from the command line if you were manually updating the directory. So it's really the same program that actually updates the directory. DirMaint uses the directory in the source form in a different format for its own manageability, but in the end, it's DirectXA that's writing that object directory. He can monitor user passwords, so if you don't have a security monitor, he can let users change their passwords that are in the directory. Can even tell you they've expired, although he can't really enforce it too well. You really need a security manager. But it does allocation of DASD, and it allocates work to these DATAMOVE servers, which we'll see on the next page what they do. So the DATAMOVE server, kind of as the name implies, does these long-running transactions, and a lot of times that means moving data, copying a disk or formatting or something like that, because those things, as we know, take a little bit of time for all of the I/O. So, we don't want to tie up the DirMaint server doing those things. So there's another server, or it really can be a set of servers that do that. So if you want to allocate new DASD space for a user and have it formatted when it's allocated, that's an option. DATAMOVE would do that formatting. So if you would want to move a mini disk from one place to another, and a lot of times you do that to make it bigger, then it can copy the files and everything over to do that and format the old space when it's done. That's that second bullet. If you delete something, it formats it to prevent residual data there, and it can do cloning or copying of disks. So you could think of that in a Linux context. If you have like a golden image and you want to make a new Linux version by cloning, DATAMOVE could do that for you, and it can even use flash copy when that's available to make it very fast. But you can run on a single system multiple DATAMOVE servers. So if you have a lot of formatting or cloning or whatever going on, a lot of this kind of work going on, maybe when you allocate a new Linux server, you want it to happen a little faster and do things in parallel, you can actually run multiple DATAMOVE servers, and DirMaint will allocate the work out to the ones that are free to do the work and that kind of stuff. Now, this other server called DIRMSAT, or the satellite server, is important and really required in an SSI cluster. Those are those guys that synchronize the directory and do those updates and relay things back and forth to the primary DirMaint server. They're running on the members that are not running the DirMaint server. So it's mainly in communication with the DirMaint server to know when to make an object directory update or something like that. So it puts that online update on its system, but it can route commands back and forth. So you would have one copy of a DIRMSAT server, and they have unique names because these are all single configuration virtual machines, meaning we're not using the identities and the subconfigs and stuff. And the reason for that is so that I can use spool files to communicate from one to the other. So they have a unique name. And so DIRMSAT2 probably normally runs on SSI cluster member 2. DIRMSAT3 runs on 3. DIRMSAT typically runs probably on the first member of a cluster if DirMaint is not running there. If you would sort of accidentally have DIRMSAT running where DirMaint is running, not much happens. It just doesn't do anything. So let's talk about installing and configuring DirMaint. It's, like I said, pre-installed. It's one of those 4 optional features that comes pre-installed. You can license them if you want to use them, but if you don't want to use them, you just leave them there and ignore them. So if you want to use it, of course, you've paid your license, you enable it, and you use the VMSAS commands to do that. So those 2 things, enabling in system config and enabling it to VMSAS, are basically done by a VMSAS command. Of course, you got to configure it, and so we'll talk about that. Eventually, you make sure that you do a put to prod, that the DirMaint code is in production, and then, of course, you make sure it's started up automatically when your system's IPL'd. The default profile exec on AUTOBLOCK 1 does that automatically, actually looks to see if it's configured and where it should run. But if you've modified that or whatever, you just need to make sure that DirMaint does get started up at IPL time. So the product code is actually, there's a bunch of these type of IDs on the system. If you've looked at a system 7 for version 7, VM, and then the 3-letter, there's kind of a 3-letter code for all of the components of VM. So DIR is for DirMaint. This, of course, is 7.1 or 7.10. So that's the installation and maintenance user ID for DirMaint. And so that's what owns the disks, basically, the service disks and the production disks and things like that. And so in the directory that comes with the system, it's all set up. And so there's very little you really need to do. You certainly don't have to do anything to set up the ID and stuff. You just need to go through that process to configure it. The DirMaint Tailoring and Administration Guide is really the book that tells you all the details about tailoring. The program directory is also good to look at. The memo to users, of course, tells you how to enable it. There's certainly those kind of things that come with the system. So the configuration files of DirMaint, these set of things we're kind of talking about 2 different kinds of files here. There is another one called auth4. That really has you configure DirMaint itself. And so these config.xx or config*, you see it documented that way. We'll talk about the structure of that basically, but that's a set of configuration files and overrides, if you will, that do the basic configuration of DirMaint. And this one called config.ss defines the satellite servers in an SSI cluster, and that one's pointed out because the installation process creates that file. And so it's actually not a file you need to create unless you add members to your SSI cluster, but it's a file that's already there. And the extent control is what defines this automatic mini disk allocation. So we'll certainly talk about how that works. So config DATADVH is the basic configuration file for DirMaint. It's kind of the master configuration file. And it's a pretty big file, has a pretty large number of customizations options. DirMaint is very customizable, although most people don't do much customization to it. But it has a lot of things that could be customized for different situations. So you can see there directory update, restart, recovery, security and auditing characteristics. So if you are working with RACF with DirMaint, then you need to configure that. So that needs to be configured, how you're controlling passwords and all that. But this file that does exist, config DATADVH, is not something you ever modify. You basically override it. You create override files to change that. So there are other products and components that do that kind of thing. The reason you don't change config DATADVH because IBM changes config DATADVH as services added or new features, new functions added to DirMaint. We've certainly seen that happen. And so they ship a new version of this file with new configurations that go with those changes. And so you don't want to change that. So you create another file that starts with the 6 characters config, and then you have a 2-character suffix, whatever you want to choose, and it has the file type DATADVH. And basically, as it says there, you typically use the letters or the numbers. And in essence, if you're looking for a setting, you would look in reverse alphabetical order if you're looking for the first time that appears. I also like to think of it as that every config file overrides the previous one. So, the last one wins. It's getting to the same end, basically. The file in the highest part of the alphabet is the one that has the setting that's used in essence. So don't get too wrapped up with that. Probably you would keep your config files, not too many of them. You'd keep them, the naming pretty simple, and you probably wouldn't duplicate settings within all of the files, just so you don't get all lost as to which one is actually doing the override. So here's a little bit of a very small part of the config DATADVH, and it has a lot of comments in it too, and so we're not showing that here. But you can see some of the kind of things that are in there. And I'll just point out that they were kind of clever. So, like it says run mode equals, and the spacing doesn't matter. It doesn't matter if there's a bunch of spaces or no spaces. Run mode equals testing. You notice there's a vertical bar there, like an OR symbol in Rex, or operational. Well, basically this setting is run mode equals testing, and DirMaint considers this vertical bar to be a comment character, the start of a comment. So it kind of reads nicely that, oh, what do I put in that setting? I can put testing or operational, which is true. But the setting in config DATADVH is run mode equals testing. And guess what? We're going to want to change that. But that is a comment character. So it's kind of clever the way they did that. The other thing they did is that a single slash starts a comment. So if you want to just put a slash in column 1 or somewhere, you can comment out a line. If you want a slash asterisk for a Rex style comment, then that's fine because it starts with a slash, and then the rest of that line is a comment. So that's just a little bit about the format of this file, but it's readable, meaning you can read that online is offline. Well, again, that's probably something we need to change, but a lot of these things you may not need to change. Like, do you want the directory sorted? Well, you can change that, but sort directory equals no is the default. That kind of stuff, you can see those kind of things in here. And there's a lot of different things in here, like I said. I'm not going to try to go through much of it at all here, but basically show you enough to get you started. So like I say, here's a few that we really got to change. DirMaint starts up in testing mode, so you can give it a source directory, you can play with it, you can make changes if you want, but actually none of them are put online, which can be a little bit handy, but you wouldn't want to run that way too long because it's basically kind of confusing. You seem to be making changes, but you're not. So you want to make it run in operational mode, and you typically want directory changes to be put online immediately. And you notice the default was offline. Never put online at all until you tell it. Long ago, with much slower systems and much more users on it, they may have just put directory online every hour because it actually was a kind of a load to the system. But these days, it's pretty trivial as far as putting those changes online. So you want the online changes to happen immediately. Do I have a DATAMOVE machine, and where is it defined? So you have to define that, otherwise it will basically ignore your DATAMOVE machine. Now, in an SSI cluster, when you've installed it, we'll see that it basically defines the DATAMOVE machines also in that other file. Do you want DirMaint to clean up disks after they've been deallocated? So that disk cleanup equal yes. The default is no. It will just basically unallocate the space, and if you reassigned it to someone else, there may be residual data there. And typically security rules say you can't have residual data, so you'd want to make that yes. So that's just a few of the things that you can change. Here's this CONFIGSS DATADVH that was created by the installation process of the system. So when you go install the system, it creates this file, and it does this just as a help, basically, because you told the system, the installation process, what the names of your VM members are. So it can basically fill in what is the satellite server that goes with that member and what is the DATAMOVE machine that goes with that member. And then it would have, those IDs defined in the directory. They're already there. So it's there. You don't have to change it. Like I said, if you don't want to, you could, like I say, add more DATAMOVE machines to every member if you wanted to. If you would add a member to the cluster, of course, you have to change this to add them in there also. But it's just kind of a help that it's there already. That's just another override file. And you notice this one, I don't have just a single value of satellite server. This is actually defining multiple satellite servers. This is not one is overriding the other. There are certain statements that are that way. So extend control. This is an important file because we've talked about DirMaint can do automatic mini disk allocation, and this is what defines where it's allocating things. You don't want to just pick any volume on your system. You want to be able to have some control as to where things go. And so that's how we define that. So this file is also one that goes on the DirMaint OneDogFox disk. I mentioned that early on. That's kind of an important disk. Well, it is to DirMaint, but sometimes it's kind of nice just to know that it's there because that's where some of these configuration files reside. You can have DirMaint basically send you a file to update it, but it's also kind of nice to know where to go looking for it. So that's on that disk that is also there with the directory. There's a backup of that disk already automatically made by DirMaint. It's the One Dog Baker. So here's a default extent control file, basically what you'd see when you first install DirMaint. There's nothing in it, basically. Well, there's going to be a little bit more than this, but there's not going to be anything where we're going to really talk about regions and groups. The SSI volumes part will be filled out when you did the install, and that doesn't matter unless you're adding another member to the cluster, what that really is. So I don't really talk about that. The exclude part, though, it has more in it. And when we talk about exclude, it basically, they've added several things that are in the default directory that needed to be excluded. So you will see a bit more here. You don't normally really need to fill that out unless you, again, add user IDs and mini disks to the system. But we'll talk about what all these sections mean as we go through this. So the region section, so that first part that's at the top, what's a region? Got to know what this is for mini disk allocation before we get to the other parts. So it's, as it says, a basic unit of allocation or DASD segmentation used by DirMaint. It's a single contiguous area on a single DASD volume. A single contiguous area on a single DASD volume. You can have more than one region on a DASD volume. So you see this guy here has two regions. This user pack 2 has region D and region E on it. You'll notice these definitions here. So this is what this section looks like. This line is a comment. There is an asterisk in the file itself. But here I have a region ID called region A, what volume it's on, so LNX V04, where it starts, cylinder count, where it ends, this is the cylinder number, and what type of device it is. So region A takes up, let's say, part of this volume, if this is like a mod 3 volume, a 3000 or so size volume. So it takes up part of this volume. You'll notice region C takes up the entire volume of user pack 1. It starts at 1, it goes to the highest cylinder that know about, so to the end. How does it know what the highest cylinder is? That's based on this device type. So DirMaint knows that when you code exactly this string 3390-03, not just 3, it has another file that basically says this is a 3339 cylinder volume. So I know I can go from 1 to the very end of that volume. It takes up the entire volume. And like I say, this one, D and E are on the same volume label, user pack 2, and they have a couple different extents in there from 1 to 1000, from 1500 to the end. Now, typically what people do these days is they don't do this multiple regions per volume. There were kind of reasons to do that, but not really good reasons these days to do that. Typically you put one region on a volume, and usually it's the whole volume. It doesn't have to be, but usually it is. And so very frequently the region ID, they just use the volume serial, the label that's on the pack as the region ID. It makes it a kind of a lot easier to think about. You don't have to think about two different unique names to do this. There really isn't a real good reason to do it otherwise. So typically you see these lines where like this would say user pack 1, that's fine, 1 to end, and what device type it is as you define regions. But any volume that you don't reference in this region, by vols here, DirMaint won't allocate mini disks on it. You have to sort of fight with it to get a mini disk allocated on there because he doesn't know about it. This is how you tell it basically where to put things. So that's the whole important message about regions. If you don't define a region for a disk, then DirMaint basically doesn't know about it. He's not going to allocate mini disks on it. He's going to basically complain if you try to put a mini disk on there when adding a user, that kind of stuff. So that's why you put all of your disks where you're allocating, having DirMaint allocate mini disks on it in this section of the file. So the groups is how you can basically group regions together, a collection of one or more regions. So you have a group ID, and then you just list out the regions that it makes up. And if it takes more than the width of the normal width of the file, you typically stop about column 72 or so, typical card image heritage stuff, then you just repeat the line with the name of the group and more regions. A group can have, I don't know what the limit is on the number of regions, but it's a lot. I wouldn't worry about it. So like I have a system group and a Linux group over here. So I'm using, and that would make up these regions. The system group would make up these system A, system B regions. And this is typically what you work with. You're going to allocate a disk to Linux. Well, I just allocate it in the Linux group, and it will find free space in one of the regions to allocate the disk. If it comes back and says there's no space, then what do? You add more regions and you put those regions into that group, and then of course you can go and allocate those disks. So typically that's what you're working with, the groups itself. So that's those two sections. The exclude section, there are mini disks that, as it says, deliberately overlap other mini disks. Typically, there's like a mini disk to actually write the directory under main. There's the 123 mini disk, which basically is the entire res pack. It overlaps the whole thing. And the reason for that is so it can write the directory wherever the directory cylinder's on. It can find them and get to them. Or a virtual machine for system backup, maybe having to read an entire disk and dump it onto a tape or whatever it does with it. And so you want to be able to read the whole volume. You can't attach a volume that's used by the system, meaning has mini disk on it, to that ID. You have to basically go through a mini disk. So basically we have, in the exclude section, we basically say ignore these mini disks. That's really what we're saying. When you're looking for free space, when you're seeing what's used, ignore these mini disks. And so here's some examples. You can use wildcards, asterisks in there, so you don't have to list every mini disk that's out there. You can say, oh, all my backup dash whatever. These are maybe subconfigs. Ignore those disks when you're doing disk allocation. So that's what those are for. Now, an example of this, to show you why you have possibly need excludes and why you have full pack overlays. Let's say I have mini disks on here. Here's 3 mini disks of smaller size on this user pack 1, but I also have this mini disk owned by a backup user ID that spans the entire volume, 0 to end. So that's the whole thing on user pack 1. DirMaint, if you didn't tell it to ignore this entry, would basically see this volume as fully allocated. Hey, I can't put any more mini disks on there. There's this mini disk that's already allocating the entire volume. And so I can't do anymore. Well, you want DirMaint to ignore this mini disk definition. So either by address or by user ID or both in the exclude section. And now he says, okay, I'm ignoring that. And now I know that, maybe there's free space in between here or whatever. We don't know exactly where the free space is, but I can do more disk allocation on this disk. So that's exclude. It's important. And like I say, there is, for the basic system, when you first get the system installed, the extent control that comes as a sample has an exclude section. And it basically covers those various maint disks, pmaint, those kind of things, otherwise cause you allocation problems. So it excludes those volumes, but you may have to add to it depending on what else you are allocating. So we talked about in the region section up here, these DASD type model associated. You didn't tell it in there, this is the maximum number of cylinders on this disk. You basically said it's this kind of disk, which is handy because typically your DASD people would give you a certain, okay, we have a bunch of this style and that kind of stuff. So as we just saw in that region section, we have those device type and models associated with it, as I was saying here. They have to match exactly. And so there's a file called defaults DATADVH on one of the disks, either the 1.1fox or the 1dogfox. And basically that has DirMaint's default. So in the extent control that we saw as the sample, it said 3390-03. Notice this says just -3. 03 is defined in defaults.DATADVH, and it's actually this number, 3,339, or 09 one is 10,017 cylinders. That's the normal size of that. So you could use those. But once you get above that, you might say newer sizes or bigger sizes, then the way disk storage subsystems work, they can a lot of times pick sort of any cylinder count or multiples of a mod 1. There's different definitions of what is a mod 27 or what is a mod 54. And when you get into EAV volumes, there really is no standard. There's different counts of that. So, and you probably have those kind of DASD on your systems these days because, mod 3s are really tiny and they're not that common very much. So you probably will need to add in the default section what geometries of your DASDs that you have, or if you have fixed block architecture, how big is the LUN? LUNs can be different sizes. How many blocks is that? You probably have to put something in there for the maximum size of that. So where in the past we could say, oh, just use one of the standard things that we have, and that's fine. Well, you probably need to put something in there because there really aren't that many. There's a couple of them, but really probably not exactly what you need to define the maximum size of the cylinders for the devices you have. If you would tell it it's a mod 9, then it's only going to allocate through that 10,017 cylinder, and it's never going to allocate anything higher because it doesn't think it's that big. If you tell it it's a device type that's bigger than the actual disk, then it will try to allocate, but you won't be able to use those disks when you log on. So anyway, you probably put in a model number probably a model number dash something, and then the maximum number of cylinders that's in this default section. So that is a section that you would probably be filling in. The auto block section is basically if you want DirMaint to automatically format, and it's kind of a conversion kind of thing of how that's done. Typically, you wouldn't do anything with that section. So let's try to get through some commands here. We've kind of spent a lot of time on background, but I think the background's important to get things set up. It's a command line based thing. You basically, if you want to change the directory, there just about always is a command to do it. You don't have to basically go in and edit the directory entry manually. You can do that, but if you want to add a link, if you want to change the mini-disk statement, change a password, add an option, there's a command to do that. So they very typically mimic the format of the directory entries. And fortunately, we have help available for looking at those commands, and there's a command authorization. So it's the DirMaint command, or its abbreviation DIRM, which I typically use, and that's how you issue these commands. Here are the command classes. They're not, A through G like CP, but they have a more of a mnemonic kind of thing. Typically, it's like CP. If you're a command class G general users, like you can just do things for yourself, that's what you have. If you're a system admin, you probably have most of these other authorizations, so you can do whatever you need to do for the other virtual machines. Here's the help. Easiest way to get to the help is DIRM ? And then it'll invoke the help command, which is this help ADVH menu. So that's not as easy to remember. So I typically just type DIRM ? And you see the commands that are there. And usually when I'm trying to make a change and I want to find the command, I just look at this screen and look at help for the various commands till I find the one I'm looking for. Like these set guys, if I'm trying to set the CPU or something like that, set an option, what is the command for that? Some of these commands are based on an older version of DirMaint, and maybe that's why you have to kind of look a bit for the command you're looking for, but they are there. So depending on what you're trying to do, there's probably a command, or there should be a command for it, and you can look at the syntax of that command to do that. So here's some simple ones: changing my password, DirMaint or DirmPW. It prompts me. If it's RACF, it would go to RACF. I could change somebody else's password if I have that privilege to do that. And that's typically you use the for override. There's overrides to DirMaint commands. So for the Bob user ID, I'm going to change their password, or I'm going to add a link for the Bob user ID. If you're administering DirMaint, if I want to put a file on one of DirMaint's disks, which I can do, like I'm changing extent control, that's a file that's on its disk, or I can put a prototype directory on its disk, as we'll see here. I can do that, or I can have DirMaint send me a file off of its disk, so give me the current extent control file, because I want to modify it. There's commands to do that. So let's talk about adding mini-disk, the add mini-disk command. The way this command is structured, and you notice I'm saying for another user, add mini-disk or AM disk, the position of the operands on here is based on basically where they are on the mini-disk statement itself, the mdisk statement in the directory. So it's the virtual address, the device type. Now where we would normally have a what cylinder to start in, the starting cylinder, and this is the number of cylinders, I have this keyword auto region. What I basically want to do in this, so this is the name of the region where the volume serial number would be. So you'll notice I've just replaced a couple things that DirMaint needs to fill in, but otherwise I've kept these other guys in their position. So if you're looking at a mini-disk statement, you kind of know the syntax of this command already. And this is the automatic link mode. So these auto guys, here's auto G, auto by group. The other one is auto by V, auto by volume. That's where you put that keyword where you would normally put the starting cylinder. And then this, where the label is, depending on what you put here. This is a region name. This is a group name. If you did auto V, it'd be a volume ID. And basically you're telling DirMaint, find this amount of free space, 10 cylinders, in this region or in this group or on this volume, and allocate the mini disk there. You notice here user group is these three regions. So it's going to look on three different volumes in this user group example to look for that space. So that's the basic add mini disk command that would get used quite a bit. If you're allocating a full pack disk, meaning the entire disk, well, you would just basically tell it the number of cylinders of an entire disk. And of course, the only place it could satisfy that is basically an empty volume, but that's certainly what it does. So how do you create a user ID? It's the DirMaint add command to create a virtual machine directory. And you basically create a file with Xedit, or you have a file on your A disk that has the new directory entry in it. So it would have a file type of direct. It would be like on your A disk. So add, in the name of the user ID or the name of the identity. It's basically the name of that file. You can also create something called a prototype file. If you always create certain user IDs, like a Linux server, a certain way, then you can create this file called a prototype. And then it's a template for new user IDs. And it basically has an AMD, an add mini disk statement in it to say, this is the type of disk or disks that I need to add. So the syntax of that command, so this is just dirm add, an ID called Bruce. So dirm add Bruce. But this one is dirm add user, the name of the user ID, Bruce, like a prototype I created. And I also need to give it a password, an initial password, because the password in the prototype is ignored. So that's how you can create a series of things that are all very similar. Here's this as an example. Dirm add James. I have this file, James Direct A, on my A disk. You notice I have the password in there and everything else that defines that user ID. These are all directory statements in essence. This is actually a DirMaint command, add mini disks. So I don't put an mdisk statement in there. If you did, it basically just DirMaint still takes it as an add mini disk command. And then I give it an add mini disk statement with auto group, the name of the group, the size of it, that kind of stuff, as you might expect. And when that's added, he obviously puts that entry into the directory file, goes through the add mini disk process to create that mini disk. If it's successful, then that user ID is added to the directory. If it fails, like there isn't enough space or that group doesn't exist or something like that, the whole transaction is rolled back and that user ID is not added to the directory. And you have to, of course, fix it by either fixing the file or adding space to the group or something like that. Whatever, depends on what went wrong in there. Here's how we use this prototype directory. So I have this file called general user protodir that I've put on one of DirMaint's disks. It's on his A disk. And you notice it says user, gen user, gen user. This stuff is ignored, the user ID and password. The rest of this is used. And you notice it has an add mini disk statement for a group. So if I dirm add Sheila like gen user, and I also give it a password for Sheila, then basically DirMaint takes this file, replaces gen user here with Sheila, replaces this field with the password I gave it, and of course it adds the mini disk and creates that user ID. So I don't have to basically have a file on my own A disk or modify it with all the basics of the directory entry in there. I put that on DirMaint's disk so that me and my other 4 system programmers or whatever all create these users the same way because I'm using the same prototype. If I'm creating an identity, so these are multi-configuration virtual machines, that are different on every member of an SSI cluster and can be logged on to every member of an SSI cluster. I still create a directory file on my A disk, or I could use a prototype directory if I wanted to. But you notice, if you remember how these are structured, normally they have build on lines, build on, this system using subconfig. Those aren't there because what I'm going to do is I'm going to add this to the directory first, and I can't have a build on line that points to something that doesn't exist, a missing subdirectory. That's not legal. That would give me an error in DirectXA. So I create this with no subconfig line, and it's in the directory. It's sort of useless. You can't be logged into, but it's there, but I need it there for the next step. So I create the identity. Then I create the subconfig directory entries. So I put them in a different file with the file type of direct, and notice it says subconfig in the name of it. And it has the mini disk. We will add a mini disk in there, one on here. So these two are different because they are 4 different systems and they use different volumes, probably private volumes on those systems. And so use this DirMaint command to add that, a subconfig. Dirm add the name of the subconfig. But then I tell it, what system is this for? It's built on what member name, BM01, in the identity. So that's how you add a subconfig. And so what that does is, of course, it adds this directory entry to the system, but it also basically adds this build on statement to the identity, which we'll see in a second what that really looks like in the end. So that's how I add a subconfig that's associated with an identity. And of course, I can do that for VMO2 also. It's a multi-step process to create a multi-configuration virtual machine, but that's how you do it. You create basically the identity file, a subconfig for each member, and then you have a command to add them in for each member. So this is what's in the user directory. You notice this was basically what I had, but now these build on statements have been added by DirMaint and in separate directory entries. So it shows them together. These could be somewhere else in the file or whatever. They aren't really part of this directory entry, but there's a subconfig, and they're added to the system. How do I get rid of a subconfig? Well, I basically delete the subconfig, and it will delete this line also. Or I can add another subconfig and it will add another line, that kind of stuff. If I want to delete the whole thing, I can delete the identity, and I think it all goes away at once. But basically, I can't have a build on line that points to a subconfig that doesn't exist, and I can't have a subconfig in a directory that isn't referenced by a build on line. So that's how DirMaint takes care of that. So that's how you create an identity. So again, really basic stuff as far as the basics of creating a user ID and adding a mini disk are really important. Otherwise, making other changes to the directory are really just finding the command, and which can either add something or delete something, add a privileged class, take away a privileged class, whatever. But there's even commands to change user IDs, move mini disks, change the virtual addresses of mini disk, add links. All of those kind of commands are out there for DirMaint to do that. And there is a command to just get the directory entry, and I can make manual changes to it if I would happen to need to do that. And then you replace it out there and all of that kind of stuff. Let's see, prototypes versus directory profiles. I didn't talk about directory profiles because that's really a directory thing. You mean something that's in the user directory. DirMaint can work with directory profiles, meaning when you do a dirm add, if what you're adding is a profile, it starts with a keyword profile, then DirMaint will add that to the top of the directory where the profiles go. And you can basically work with a profile just like you work with a user ID. And so that's how you work with a profile. And then how do you use a profile? Well, it's an include statement in a directory entry. So when you build that directory entry, you would basically say include and the name of that profile. If that profile didn't exist in the directory, when you tried to add it, you would get an error and it wouldn't be added. But DirMaint certainly has the commands to work with those, but it's really just kind of working with them just like you would work with other statements in the directory and the other directory structures. But yes, I didn't mention that a profile is sort of treated like a user, well, it is a directory entry. And so it's treated like a directory entry, just like user directory entries, identities, subconfigs, that kind of stuff. And the same commands work with them. Starting and stopping, of course, DirMaint needs to come up on your system when you start it up. Otherwise, it doesn't do anything. If it would go down, then your system keeps running because your object directory is there. You just can't change it. So that's why you need to make sure it starts up when the system starts up. If it's an SSI, you need to make sure DirMaint starts up on one member and satellite servers, the appropriate ones, start up on the other members. Fortunately, the profile exec that comes with AUTOBLOCK when you install the system basically has the logic in there already to do this for you. It looks to say, well, have you enabled DirMaint? If so, then I will start up DirMaint. If DirMaint isn't running anywhere, if DirMaint is running, I will start up the correct satellite server on this system. It does that for you, which is nice. DATAMOVE is automatically started by DirMaint, so you don't have to start it up either. So it can look and say, okay, these are the DATAMOVE servers that are for me, and so I will start them up, and so they'll be available when the system comes up. So that's nice that part's already done. If you want to shut down a server, to shut DirMaint down, it's DIRM shutdown. So this is one of these deals where I hope you've specified requiring the system name on the CP shutdown command, because if, people have stories, oh, I forgot to say DIRM before I type shutdown. Guess what happened? Your system went down. So another good reason, because unfortunately, some of these subsystems use the same command basically to shut themselves down. So anyway, DIRM shutdown shuts down the server. You can shut down a satellite by telling it what one to shut down. You can say DIRM DATAMOVE shutdown and which one. There are commands to shut every one of those down. And it's nicer to do it that way in case there's something in process that will get finished before it logs off. So pretty basic overview. Tried to give you some details. I guess I pretty well covered my hour, which is good.
Bruce, thank you very much for presenting today.
Thanks for watching. If you enjoyed this video, don't forget to like and subscribe to see more videos like this one. Have a suggestion for another video topic? Feel free to leave a comment below.